Good morning, students. In this session, we will be discussing the conversion of f of x by g of x, which is a proper fraction in the power series of x. So, we have the binomial theorem for the positive integral index 1 plus x whole power n is 1 plus nx plus n into n minus 1 by 2 factorial into x square plus n into n minus 1 by into n minus 2 by 3 factorial into x cube and so on. So here n is the positive integer. So if n is the positive integer, then the number of terms will be finite and those are n plus 1 terms. For example, 1 plus x whole square if you take, since n is equals to 2, which is a positive integer, we will be getting 2 plus 1, totally 3 terms. So 1 plus 2x plus x square, a plus b whole square, a square plus 2 into 1 into x 2x plus b square x square. Likewise, 1 plus x whole cube, so a cube plus 3a square b, so this is 3x plus 3ab square, 3 into 1 into x square plus x cube, b cube is this. So if the power is 3, then we will be having 1, 2, 3, 4. So 3 plus 1, 4 terms we will be having here. So let us see 1 plus x whole power minus 1. So here in the place of n, we see minus 1 here. If you substitute here 1 plus in the place of n substitute minus 1 into x plus minus 1 minus 1 minus 1 is minus 2 by 2 factorial into x square plus minus 1 into minus 1 minus 1 is minus 2, minus 1 minus 2 is minus 3 by 3 factorial into x cube plus so on. So this is equals to 1 minus x minus into minus plus 1 2s are 2, 2 factorial is 2 into 1. 2 gets cancelled, x square, minus into minus plus, plus into minus minus. So 2 3s are 6, 3 factorial is 3 into 2 into 1. So 6 by 6, x cube, plus, and this goes. Therefore here, what we have seen is, if the power n is rational number includes both the negative integer as well as p by q form, then this leads to the infinite number of terms. So likewise, 1 minus x whole power minus 1, we will be getting 1 plus x square plus x cube plus so on. So if we want nth kth term here, minus 1 whole power k into x power k plus so on. So here the kth term is x power k, etc. Likewise, so 1 plus x whole power minus 2 is equals to 1 minus 2x plus 3x square minus 4x cube plus etc. plus minus 1 whole power k into k plus 1 into x power k plus etc. So here in the place of n, minus 2 if you substitute, then this is what we will be getting. So you may check it out also. N equals to minus 2. So minus 2 into x. N is minus 2. Minus 2 minus 1 is minus 3 by 2 factorial is 2 x square. So here minus into minus plus 2 gets cancelled, 3x square. Likewise it goes. And if we want the 1 minus x whole power minus 2, it will be 1 plus 2x plus 3x square plus 4x cube plus etc. plus k plus 1 into x power k and so on. This is the kth term. So these are the power series expansions. So for the expansion to be valid, the n should be a rational number with mod x is less than 1. That means this x should be lying in between -1 and +1. So these are all the power series expansions. These expansions can be used to express the proper fraction as the power series of x. Let us discuss the first question. Find the coefficient of x cube in the power series expansion of 5x plus 6 by x plus 2 into 1 minus x, specifying the region in which the expansion is valid. First of all, take this fraction. Which kind of fraction it is? Proper fraction. X power 1, here x into x, x square. So degree of numerator is 1, degree of denominator is 2. So given proper fraction is 5x plus 6 by x plus 2 into 1 minus x. So the denominator contains non-repeated linear factors. So type 1. For every non-repeated linear factor of ax plus b, this is the non-repeated linear factor. For every non-repeated linear factor of ax plus b of the denominator g of x, there will be a partial fraction of the form a by ax plus b. So this is equals to x plus 2 is a linear factor because this can be written as 1x plus 2, where a is equals to 1 and b is equals to 2. So for there are two non-repeated linear factors for which two constants we are going to take, and those two constants are to be evaluated. A by x plus 2, b by 1 minus x. This is equals to 5x plus 6 by x plus 2 into 1 minus x is equals to a into 1 minus x plus b into x plus 2 by x plus 2 into 1 minus x. Denominators gets cancelled on both the sides. So therefore 5x plus 6 is equals to a into 1 minus x plus b into x plus 2. Now x plus 2 is a linear factor. X equals to minus 2 is the root of solution. 1 minus x is the linear factor. X equals to 1 is the root of solution. So x equals to 1 and x equals to minus 2 will be taken to substitute for the value for x. Put x is equals to 1. Substitute. 5 ones are 5 plus 6, 11. So this is on substitution of 1 in this, it will be 0, 1 minus 1, 0. So b into x plus 2, 1 plus 2 is 3. So b is equals to 11 by 3. Put x is equals to minus 2. 5 into minus 2, minus 10 plus 6 is minus 4 is equals to a into 1 minus of minus 2. So 1 plus 2 is 3. This is equals to a is equals to minus 4 by 3. Therefore 5x plus 6 by x plus 2 into 1 minus x is equals to The value of A is minus 4 by 3 by x plus 2. Minus 4 by 3 into x plus 2 plus the value of B is 11 by 3 by 1 minus x. So 11 by 3 into 1 minus x. So this is equals to minus 4 by minus 4 by 3 into this is 1 by x plus 2 is x plus 2 whole power minus 1 plus 11 by 3 into 1 minus x whole power minus 1. This implies this is equal to minus 4 by 3 into, so x plus 2 whole power minus 1. So this can be written as 2 plus x whole power minus 1 plus 11 by 3 whole power 1 minus x whole power minus 1. So minus 4 by 3. This we have to write in the form of 1 minus x whole power minus 1 or 1 minus x 1 plus x whole power minus 1. So here 1 should be there, for which 2 I will take common, then we'll get 1 plus x by 2 whole power minus 1 plus 11 by 3 into, this is already in that form only, so 1 minus x whole power minus 1. So this is minus 4 by 3. 2 power minus 1 is 1 by 2 into, now this is the form 1 plus x whole power minus 1. 1 plus, let us suppose this x by 2 to be x. So 1 plus x whole power minus 1, the formula for which is 1 minus x plus x square minus x cube plus etc. plus minus 1 whole power k into x power k. This is the kth term plus etc. Now this is equals to 1 minus, in the place of x here x by 2 we have, so this is x by 2 plus x by 2 whole square minus x by 2 whole cube plus etc. plus 1 minus x whole power minus 1 is 1 plus x square plus x cube and so on. So this is equals to 11 by 3 into 1 plus x square plus x cube plus etc. Since we want the quotient of x cube, so until x cube I have written. Now minus 2 times, so minus 2 by 3 into the coefficient of x cube here is, this is minus x cube by 2 cube. So the coefficient of x cube is minus 1 by 2 cube. So this is equals to minus 1 by 2 cube is 8 plus 11 by 3 into the quotient of x cube is 1. So 1 into 11 by 3 is this. So minus into minus plus 2 4s are 8. So 1 by 4 3s are 12 plus 11 by 3. So the LCM is 12. 12 by 12 is 1 plus 12 by 3 is 4. 4 11s are 44, which is 45 by 12. So if you cancel third table, 3 15s are 45 by 3 4s are 12. So this is the answer. Find the coefficient of x power 4 in the power series expansion of 3x square plus 2x by x square plus 2 into x minus 3, specifying the reasoning in which the expansion is valid. So given fraction is 3x square plus 2x by x square plus 2 into x minus 3. So this is again a proper fraction with the degree of the numerator is 2 and the degree of denominator is 3. X square into x is x cube. So again it is a proper fraction. So both are the polynomials in x and the denominator contains x square plus 2 non-reducible or irreducible non-repeated quadratic factor. X square plus 2 is of the form ax square plus bx plus c, where x quotient is absent. Yet it is the quadratic factor only. Which quadratic factor? Does it have the factors? Does it have the factors? No. Because if you solve this, b square minus 4ac, the discriminant is going to be less than 0. So that is minus 8. Minus 8 is less than 0. Therefore, it doesn't have the real factors. Now, this is irreducible, non-repeated irreducible quadratic factor type 3. X minus 3, non-repeated linear factor. This is the combination of type 3 and type 1. For every non-reducible or irreducible non-repeated linear factor, there exists a partial fraction of the form ax plus b by x square plus 2. This is c by x minus 3. This is equals to 3x square plus 2x is equals to ax plus b into x minus 3 plus c into x square plus 2. Denominator on both the sides gets cancelled. Put x is equals to 3 and substitute 3 square 9. 9 3s are 27 plus 2 3s are 6 is equals to, this will be 0, c into 3 square 9, 9 plus 2, 11. So this is 33 is equals to 11c. So c is equals to 3. Now comparing the coefficients of x square on both sides. So x square quotient is here 3. Here ax into x, ax square quotient is a. Here quotient of x square is c. So a plus c is equals to 3. From this, a is equals to 0. Because this is 3, c is 3, 3 gets cancelled, a equals to 0. Now comparing the coefficients of x on both sides. So here x quotient is 2. Here ax into x, ax square minus 3ax. So x quotient is minus 3a. Plus bx, x quotient is b. So from this, 2 is equals to minus 3a is 0 plus b. So from this, b is equals to 2. Therefore, 3x square plus 2x by x square plus 2 into x minus 3 is equals to ax plus b. So a is 0. So we are left with b by x square plus 2. B value is 2 by x square plus 2. C value is equals to 3. 3 by x minus 3. 2 by x square plus 2. Take 2 in common. This is 1 plus x square by 2 plus 3 by, take minus 3 in common, then we'll get 1 minus x by 3. So we want 1 here because we have 1 minus x whole power minus 1, 1 plus x whole power minus 1, 1 minus x whole square whole power minus 2, 1 plus x whole power minus 2, etc. So in every expansion 1 is there. Therefore we have converted these two into 1 plus. So this is minus 3, minus into minus plus 3 gets cancelled, plus x. So 2 gets cancelled, 3 gets cancelled. So 1 by, this is 1 plus x square by 2 is 1 plus x square by 2 whole power minus 1. This is minus 1 minus x by 3 whole power minus 1. This is equals to, we know 1 plus x whole power minus 1. So 1 minus x plus x square minus x cube plus x power 4 and so on. So minus plus minus plus, it will be alternative. So here we'll get, in the place of x square by 2 is what we have here. So 1 minus x square by 2 plus x square by 2 whole square minus etc. We want the quotient of x power 4. Here quotient of x power 4 we are getting here. So under we will be getting the highest powers of x. So we want x power 4 quotient. Therefore we have stopped from here. Plus this is 1 plus x by 3 plus this is 1 plus x by 3 plus x by 3 whole square plus x by 3 whole cube plus x by 3 whole power 4 plus etc. Therefore, the coefficient of x power 4 is, this is x square whole square is x power 4 by 2 square is 4. Therefore, the quotient of x power 4 is 1 by 4 minus, here x power 4 quotient is 1 by 3 power 4, which is 1 by 81. This is equals to 81 minus 4 by 81 into 4. This is equals to 81 minus 4 is 77 by 81 fours. 4 ones are 4, 4 eights are 32. So this is the answer. Find the coefficient of x power n in the power series expansion x minus 4 by x square minus 5x plus 6, specifying the region in which the expansion is valid. So, given fraction is x minus 4 by x square minus 5x plus 6. So we should not jump to the conclusion that this is the quadratic factor, and for irreducible quadratic factor it is type 3. So ax plus b by x square minus 5x plus 6, if you write that, it will be wrong, because this is the quadratic factor, but we have to check whether it has the factors or not. Can it be further decomposed, factorized, splitted or not? So x square minus 5x plus 6, it has the roots x minus 2 into x minus 3. So the denominator now becomes x minus 2 into x minus 3, which are non-repeated linear factors. So type 1 we have to proceed. X minus 4 by x minus 2 into x minus 3. So the factors for which is, the partial fraction for this is a by x minus 2 plus b by x minus 3. So a into x minus 3 plus b into x minus 2 by x minus 2 into x minus 3 is this. Therefore, x minus 4 is equals to a into x minus 3 plus b into x minus 2. Put x is equals to 2. Substitute 2 minus 4 is minus 2. So a into 2 minus 3 is minus 1. A is equals to 2. Put x is equals to 1. So 1 minus 4 is minus 3 is equals to, put x is equals to 3. Put x is equals to 3. So 3 minus 4 is minus 1 is equals to 3 minus 3 is 0. B into 3 minus 2 is 1. So B is equals to minus 1. Therefore, x minus 4 by x square minus 5x plus 6 is equals to, the value of a is 2, 2 by x minus 2, b value is minus 1 by x minus 3. So this is equals to 2 by, this can be written as minus 2 plus x minus 1 by minus 3 plus x. So we have to convert this into 1 plus x or 1 minus x. So I want 1 here, for which let us take minus 2 in common. So 2 by minus 2 if you take common, then this is 1 minus x by 2. So minus 2 into 1 minus 2, minus into minus plus 2 gets cancelled, x minus 1 by minus 3 if you take common, 1 minus x by 3. So minus 3, yes. Now 2 gets cancelled. This is equals to minus 1 minus x by 2 whole power minus 1. So this minus gets cancelled. So 1 by 3 into 1 minus x by 3 whole power minus 1. So this is equals to, this is 1 plus x by 2. This is on the form 1 minus x whole power minus 1. 1 plus x square plus x cube plus x power 4, etc. So this is equals to 1 plus x by 2 plus x by 2 whole square plus x by 2 whole cube, etc. So we want x power n here. So x by 2 whole power n plus etc. And there are infinite number of terms in which, since we want x power n coefficient, therefore I have written this only. Plus 1 by 3 into, this is again 1 plus x by 3 plus x by 3 whole square plus etc. plus x by 3 whole power n plus and so on. Now coefficient of x power n is, here the quotient of x power n is, this is x power n by 2 power n. X power n quotient is 1 by 2 power n. Plus, here this is x power n by 3 power n. X power n quotient is 1 by 3 power n into 1 by 3. So 1 by 3 into 3 power n. Therefore the answer is 1 by 2 power n plus 1 by 3 power n plus 1. Here bases are equal, exponents are to be added. So 3 power 1 plus n. So here minus is missing here. So the answer is minus 1 by 2 power n plus 1 by 3 power n plus 1. Find the coefficient of x power n in the power series expansion of 3x by x minus 1 into x minus 2 whole square. So given fraction is 3x by x minus 1 into x minus 2 whole square. So this is a proper fraction with the degree of numerator is 1 and degree of denominator is 3. X on expansion, this is x square. X square into x cube. So degree of f of x is less than degree of g of x. Now, this denominator contains x minus 1, which is of the form ax plus b, 1x plus minus 1. A non-repeated linear factor. X minus 2 whole square is a repeated linear factor. So this is the combination of type 1 and type 2. For every non-repeated linear factor of ax plus b of g of x denominator, there exists a partial fraction of the form a by ax plus b. Here a by x minus 1 plus type 2. So b by x minus 2 plus c by x minus 2 whole square with a, b, c are to be evaluated. So this is equals to finding the LCM will get x minus 1 into x minus 2 whole square is the LCM. So this and this gets cancelled. A into x minus 2 whole square plus b into x minus 2 whole square, x minus 2. It is one time cancelled. X minus 1 into x minus 2 plus c into this by this gets cancelled, x minus 1. This is equals to 3x. Denominator on both the sides gets cancelled. Now put x is equals to 1 and substitute in this. 3 ones are 3. 1 minus 2 is minus 1 whole square is 1 into a. Directly a equals to 3 we get. Because if you substitute 1 here and here, it will be 0. Now put x is equals to 2. Substitute 3 2s are 6 is equals to 2 minus 2 is 0. 2 minus 2 is 0. We are left with the last term itself. C into 2 minus 1 is 1. Therefore, C is equals to 6. Comparing the coefficients of x square on both sides. Here, the quotient of x square in the numerator is 0. In the LHS is 0. Here, on expansion, we'll get x square. Its quotient is a. Plus, here also, x into x square quotient is b. And many terms are there. Among them, only x square quotient, only x square term is this. Its quotient is b. So, 0 equals to a plus b. From this, b equals to minus a. So, minus 3. B equals to minus 3. Therefore, 3x by x minus 1 into x minus 2 whole square is equals to a is equals to 3 by x minus 1. B is equals to minus 3 by x minus 2 plus C is equals to 6 by x minus 2 whole square. This is equals to 3 into x minus 1 can be written as minus 1 plus x. First constant I am writing and then x. Minus 3 by, this is minus 2 plus x plus 6 by x minus 2 whole square can also be written as 2 minus x whole square, because a minus b whole square equals to b minus a whole square. So 3 by, take minus in common, then this is 1 minus x. Minus I have taken common, this is 1 minus x. Minus 3 by minus 2, I take common here 1 minus x by 2. Minus 2 into 1 minus 2. Minus into minus plus 2, 2 gets cancelled, x plus 6 by 2 you take common, 1 minus x by 2 whole square. This is equals to minus 3 into 1 minus x whole power minus 1. Minus minus gets cancelled, 3 by 2 into 1 minus x by 2 whole power minus 1 plus 6 by 2 square is 4. This is 1 minus x by 2 whole power minus 2. This is equals to minus 3 into, so here 2 3's, 2 2's. This is equals to minus 3 into 1 minus x whole power minus 1 is 1 plus x square plus etc. plus n, quotient of x power n we want, therefore this is x power n plus and so on, plus 3 by 2 into, this is 1 minus x by 2 whole power minus 1. Assume x minus 2 to be x. It has become 1 minus x whole power minus 1. So 1 plus x, in the place of x, x by 2. X plus x square, in the place of x, x by 2 whole square, plus etc. plus x by 2 whole power n, and so on, plus 3 by 2 into 1 minus x by 2 whole power minus 2 is 1. So 1 minus x whole power minus 2 is 1 plus 2x plus 3x square plus etc. plus k plus 1 into x power k, and so on. So this is 1 plus 2 into x by 2 plus 3x square, 3 into x by 2 whole square plus etc. plus k plus 1. So here n plus 1 into x power n plus 1 into x is x by 2 whole power n, and so on. So this is equals to, now the coefficient of x power n is, here the quotient of x power n is minus 3 plus, here the quotient of x power n is, this is x power n by 2 power n. So quotient of x power n is 1 by 2 power n into this. So 3 by 2 into 1 by 2 power n plus. So this is x power n quotient is n plus 1 by 2 power n into 3 by 2. So this is equals to minus 3 plus 3 by 2 power n plus 1 plus 3 by 2 power n plus 1 into n plus 1.